Okay. So as I mentioned, the first folks we're going to hear from are from Safe Software. I saw a couple of people join. I'm not sure exactly who's going to be leading that presentation, but if you'd like to unmute yourself, I can stop sharing if you'd like to share your screen.
Yeah, hi Erin, it's me, Sienna. I'll be presenting this one.
Hey, Sienna.
Perfect. Can you see my screen all right?
Yes.
Okay, perfect. So I named this presentation AI, AR, and much more because it kind of rhymes, but I'm pushing it and I'm going with that. Basically, this will be a presentation about the new features that we released at the FME UC conference that happened about 2 weeks ago. So if you were there, it might be a bit of a refresher for you. But happy to answer questions along the way. I also have Chris Berger, who is here, and he can answer any questions via the chat functionality. So please don't be shy. Reach out if you have any questions about what I'm talking about. All right, so let's get started with AI because obviously this is such a huge topic now for any tech company. Um, how does FME interact with your AIs? Well, we call FME the only all data, any AI platform. And we say this because you can use any AI you want to enhance your data. We're seeing more and more AI models come out, and we don't want our users to be tied to a specific AI model or a specific AI service to help enhance their data. So we really do give you the choice to use any AI out there. Talking a little bit more about this, I have two different AI services here, and we connect to them both. We have the Azure models on the left-hand side. You can see that there's many models here, but we also can connect to the Amazon Bedrock services. We see users wanting to have the ability to connect to any AI because it allows them to use kind of the best fit for purpose model out there. When I started at SAFE, we would talk about how we allow you to use the best fit for purpose application. Well, this is just really extended now because now you can use any AI model to interact with your data as well. A little bit more on this, we also connect to Hugging Face. And as you can see, there's 1.5 million models out there for Hugging Face. So more and more, we're going to see users connecting to the AI model that best fits for their purpose, and probably using several different models in a single workspace. What's also unique about FME is we allow you to connect to any on-premise AI. So we're seeing lots of users want to use local models so that their data stays safe, reducing their security concerns. So if you can install an LLM, you can connect to it with FME as well. So let's talk about UK power networks. This is a story that we've talked about quite a bit in our webinars, but I wanted to reiterate it here. So this was done by our partner Tensing in the UK. And they're working with this very large power company that had a bunch of service records that they needed digitized for their large collection. So they already had these service cards already imported. I believe they're either like a PDF or a PNG or another kind of raster format, but they needed to extract the information from these service cards. Now, this would be quite hard to do before AI was around. But now that you have AI, you can kind of unlock this data that was previously not in your databases, not used. And so these are service cards, and as you can see, some of them are quite old. So the date of coupling in the one in the top left-hand corner is from 1912, for instance. Things to know about these service cards are all kind of different, have different formats as they've evolved these formats over time. So even as a human, it would take us a while to identify these numbers and know exactly when was this first connected and what work was actually done on these electrical lines. And they had a lot of service cards too. So over 1 million service cards that they needed to digitize and send to a SQL database. Well, they used FME to do that work for them in, as well as Google Gemini AI. So they used Azure queues to stream records to their workspace. So they're streaming 20 records per second. The reason why they're using these Azure queues is because they could send lots of data at the same time. And it would also ensure that this data was not duplicated and these records weren't being submitted twice, because Azure queuing has some logic built into it. So it knows what records were sent, what were read, and what weren't received. As well, they had an Azure storage container, and this contained just like the blob file or the binary file that was being processed here. And then they're constructing their prompt and sending it to Google Gemini AI, and then finally writing it to Azure database. And this is what their workspace looked like. So it's fairly simple. Again, you have your queue storage and then your blob connector, binary encoder to actually get that data into FME. And then from there, they're just constructing their prompt, as you can see here, and then sending that data to the HTTP caller. So this had the prompt, and it also had the binary file as well. They had some error handling, so what to do if anything got rejected. Sometimes AI isn't great at using the structured prompts. It might do something a little different, so they wanted to be notified if anything was rejected. And then they sent that all to a SQL table. So even though the workspace wasn't complicated, they're able to do some really great things. So they're able to process 1.9 million records in 26 hours. And just a bit of a fun fact, the oldest card was from 1907. Talking about costs for doing this. So the total cost was well under £200 to do that actual AI processing. Now, if someone were to do this manually, first of all, they probably wouldn't want to do it. But let's say you did have someone doing this manually, it's about 19 years of work versus 26 hours. So it's just a huge difference in what AI can do. And again, if you have any questions about AI, Chris Berger is on the call and he does a lot of our AI stuff. So feel free to reach out to him. So next I wanted to talk about general updates in 25.0. And some of these are even a little older than 25.0, but they're things I really like to highlight, especially if you're looking to upgrade your FME. So first, take a look at the product updates page. Every release we do, every new feature that comes out will be mentioned on the product, or sorry, I should say, every large feature that we make in the product will be mentioned on the product updates page. As well, the changelogs were revamped, I believe 2 years ago at this point. But the changelogs are great, and I highly recommend you look through the changelogs before doing your upgrades to see what's changed between your versions. As well, we have the security updates page. Now, if you are an FME Flow administrator, I highly recommend you go to the security updates and you subscribe for any updates. Anything that is important that needs your attention right away will be posted here, as well as the associated article, so you can go through, get those notifications, make those fixes, upgrade your FME flows. Just super critical if you are the one administering your FME flow. So go to that page, subscribe, and you'll get email notifications from us when there's something that needs your attention. Now, this one doesn't fall into AI or AR, but I think for longtime users, this is really, really exciting. So we have a new document PDF writer. The purpose of this is to help making writing PDFs a lot more efficient and a lot easier to do within FME. And as a bonus as well, a part of this work, we also added a new word reader. So before you could write to Word, but you can read from it. And this is something that's been asked for a long time. Now, what does this look like? The document PDF styler allows you to create certain types of content through FME. So now your PDFs can have things like table of contents, paragraphs, headings, images, watermarks, headers, and footers, all integrated directly into the workspace through FME. So you can create something like this, a PDF with a header, with the images, with hyperlinks, with styling, with a watermark fairly easily through FME. It just takes a few transformers to build something out like this. So we see this being a really good thing that will get lots of use in the future. And this is currently available in 25.0. So if you are on the 25.0 release, you can access this, try it out, and then let us know if you have any feedback. As well, we've improved our AI assist. So for those of you, I believe this came out in 2023, we integrated with AI, I believe 2023 or 2024, I can't quite remember now. But now we've just improved the AI assist. So now in 25, you should be getting better results if you're using it. And this is all based on user feedback. So if you haven't used it before, AI Assist can help you create Python, SQL queries, or regular expressions. And now we're going to do something with AI Assist that we have not done before, and this will be coming out in 25.1. So we can use AI Assist directly on the canvas now. So AI Assist pulls data from trusted sources, whether that's knowledge base, our documentation, or the community, and you can use it directly on the canvas. And I'll show you what this looks like now. So let's say you're just starting a workspace for the first time and you don't know what to do. Well, you can ask AI Assist what this looks like, what a typical workflow looks like, and it'll provide documentation for you about what you should be looking at and what you should do. And as you can see there, it can suggest what transformer to use, then actually help you add that transformer to the canvas. So I think this will be really useful, especially for new users who are learning FME for the first time. We're hoping it will improve the onboarding experience, so there's a less high learning curve. But AI Assist is smarter than that because it can actually understand context from your workspace yourself that you built yourself. So here we have the HTTP caller. Through the video I showed, there's a way to select the context button, which opens up AI Assist. And what this does is gives the context to what's on the canvas. So when I select that, now I can ask AI Assist a question. So this question is simple. It's what do I do next? So AI Assist is thinking about it and it's going to suggest to add either a JSON flattener or a JSON fragmenter next. So really interesting stuff there. I've also seen demos of it where it will add annotations to the canvas, where you can send in a full workspace and ask it, what does this do? What does this look like? And it will annotate your canvas for you. So lots of really exciting stuff you could do with AI Assist. If you want to try it out now, it's now available in the 2025.1 beta. So next I'm going to talk about FME Realize. So FME Realize is our AR platform. So you might know FME AR, which was a mobile app that we released quite a few years ago. Well, it's been totally revamped and changed into FME Realize. And what FME Realize does is it uses your workspaces built in FME form, then run on FME Flow to allow you to interact with the AR data through your mobile app through FME Realize. So this is what it looks like. So you take any data, so this could be surveys. This is most likely your 3D data, kind of outlines, any kind of plans. You're going to transform this data through FME form, publish that workspace to FME Flow, and then stream that workspace through FME Realize. So now you can see what that data looks like in the field. So here's a quick video, and I'll kind of skip through this for time, but we'll send out the slides afterwards, so you'll have access to this if you want to watch the whole thing. But this is what it looks like. So you have your iPad or your iPhone. You're going to a spot, probably a control point. And then when you're ready, you'll load your model through FME Realize. So here you're opening up an AR app. These are all stored on FME Flow, so you do need that FME Flow connection. And now Dimitri, who filmed this video, will be loading his model. So hit confirm, scroll down, and then hit run. So what this is doing is it's running that workspace on FME Flow. It's geolocating where the model is supposed to be. And now Dimitri can see his data. If it's not lining up correctly, he can use his fingers to move the data to the correct point. So here he is just rotating that model on his canvas, and now everything is aligned perfectly. And as he walks around, more and more data will load, so it'll constantly be refreshed. As well, FME Realize has a web viewer built in. So here he's looking at some data on the street to see the toolbox and the attributes of that data. But he can also load other things as well, like this toolbox here. So here he can see information about his fire hydrant. He could potentially be submitting a survey request or sending data. He could be looking up a YouTube video about what to do next. Again, this is just him watching the catch basin cleaning. But basically, the world is your oyster. He's even done an example of how to integrate AI with this, where a user is typing in data into a form, and then FME AI will enhance that data for him, make the language more professional, and allow him to clean up the data before it's even sent to the database. So yeah, you can watch the full video there if you are interested in everything you can do with FME Realize. So FME Realize is currently available on the Apple platform. So it's designed for iPads, but you can use it for iPhones as well, and you can download it from the App Store because it's just connecting to FME Flow in the backend. You don't need to worry about the cost of it because it's just included with your FME Flow. So you can go ahead and play around with that right now. All right, now let's talk about data virtualization. So data virtualization is essentially building an API on top of your FME Flow workspaces. So by building the API, now you can access that data very easily and connect it to applications which understand APIs. So that could be your enterprise applications, like I'm thinking ArcGIS Portal. That could be a web-based application, or that could be an AI service that you'd like to send your data to. Why would users want to do this? Basically allows you to give simplified data access and give it to a read-only endpoint. It allows you to streamline your innovation. So now you don't need to write any code to create your own API or deploy any new infrastructure. Because it's all controlled by FME Flow security, it's very secure. It allows real-time access to data without any replication. So you don't need to copy your data to another database. Using FME data virtualization, it can read data directly from the source, so you don't need to have it sitting anywhere else. Now, what does this look like? So every data virtualization journey starts in FME Flow. Here, you'll go through and you'll create your endpoints like you'd see in any API. Once you've created your endpoints, from there, you'll have to create a workspace to get this data. So using this data virtualization, it allows you to connect to FME Flow, and then that allows you to read from any database. This keeps things really secure and modular. By building these endpoints, we allow you to essentially create an API from scratch. Um, this is all with no code, and this is all Open API compatible. So especially if you're sending this data to anything like an AI, you can just send them the Open API spec, and then they'll be able to read that data. And then we automatically generate tool 2, like with Swagger documentation. So you can send the Swagger documentation to any user or AI again, and they should be able to understand how to use the API you've just created. This is what it looks like on the form side. So on the left-hand side here, we have a new reader feature type. In this case, this is the data virtualization reader, and this is performing a get request, but you could also do a put or a delete request as well. It's going to connect to a database, read information, and then using the JSON templater, it will make some JSON, which is easily sent back to the data virtualization writer. And here's a quick demo of what this looks like. So here we have a city planning API. All these tags do have to be manually created. So someone went through and created all of these endpoints themselves. These endpoints will have a path, and they'll also have authorization built in as well. And behind the scenes, for the response, we'll want to create a workspace as well. So this is just showing that the workspace is run in response. However, if you wanted, you could do something like a manual response if you want the same response every time. So this is an example showing a manual response, just information on hours, so those don't really change often. So we can just send some JSON back. However, for the workspaces, we can see all the workspaces here. So each endpoint gets a workspace. You can select multiple endpoints and say generate workspace. And this will generate a workspace for you to use now within FME form. So from there, you can build out a workspace to handle the request. So clicking this new data virtualization button, we can see the workspace, open it up, and now we'll have our endpoints that we selected in this single workspace. So there's 2 endpoints here, 2 separate GET requests. And then it also comes with this writer feature type as well, which will be the JSON that's sent back from this workspace. So after this, we'll want to build out our workspace. In this case, it will be connecting to some feature readers. This is just getting some information from a database, so getting all projects. I'm just running it to show an example of what this looks like. So you have your endpoint here. This will show we're getting all projects with a certain ID. The tester is just to say if there's any data going through. If there's no data, we're going to say, oh, there's no projects found. But if there is data, we're going to create some JSON with all the project information and send back a 200 request indicating that the workspace was successful. And then we're going to send that JSON response. So we can see what that response looks like. Again, the 200 request and all the information on the projects per the ID selected. Now, this information will be uploaded back to FME Flow. And on the FME Flow side, we can now see, yes, those endpoints were successfully configured. And this is just showing off that it builds documentation as well, all for you. So some really neat stuff coming up for us. Here's a summary of what's coming out, when it's available. So most of what I showed today will be available in the beta, which is currently you can download, but things like the PDF writer is available in 25.0. And with that, I'll hand it off to the next presenter, but always happy to answer questions, whether through this meeting or via email as well.
Thank you, Sienna, very much for taking some time to present today. Lots of, like you say, exciting tools and features coming up here. If anybody has any questions, feel free to type in the chat. I know there's a lot of information, but especially useful to those of us who couldn't attend the FME user conference. So again, thank you, Sienna, appreciate that. If there are no questions at the moment, we'll go ahead and transition over to our next presenter. Our next presenter is David Druin, who is a GIS specialist at the Louisiana DOTD. And he's going to be talking to us today about how he's used FME to improve route overlay workflows. So without further ado, David, if you want to unmute, if you want to share a presentation, go for it.
Hello, thank you, Aaron. I'll go and share the screen right now. All right, everybody can see my screen. You'll see a beautiful road. All
See
right,
it.
awesome. First, thanks for letting me present. First I'll make a minor correction. I don't know about improvement to overlays, but so I'm trying to learn FME. Kind of experimenting a little bit off and on. So I know I haven't been attending these RHUG FME meetings. Maybe I ought to start attending. But at first I learned just a few basics. Oh, I'm spoiling. Shouldn't show the slide yet. I'll give you a little intro. Just learned a few basic transformers. And I tried replicating a few Esri tools and kind of had no luck. I was about ready to give up on FME really, but gave it one more chance and came up with this tabular overlay. So yeah, it's a little bit experimental, but it was a way to learn another thing in FME. I wasn't planning on talking about AI and ChatGPT, but because of the last presentation, I'll say I'm looking forward to the AI assistant in FME because I did it the old school way, and I tried using ChatGPT for the first time with just like help with learning FME. And it was interesting to say the least. I'll give it that. It's fun. If you don't like mixing fact and fiction, I would recommend don't do it or use it as a last resort because I think it reads those transformer names as just words and then it'll try to like fill in the sentences. So effectively, it'll create transformers that don't even exist and recommend that you totally try them. But it does know some that do exist, and it recommended. It's good at just paraphrasing what you say. So I did have a plan of attack. I didn't just say tell me how to do an overlay. I came up with an idea, and it recommended the list transformers, which I've heard of but knew nothing about. So that was the one new thing I learned. But first, I'll spare you the 12 paragraph diatribe I fed to GPT and give you the simple outline of the plan here. But for an overlay, you have multiple event layers and you just want to combine them into one output. So anytime one of these attribute changes, that'll be a new record in the overlay output. So I figured since we already have all these measures in the input event layers themselves, step one, I just want to collect all those numbers and not necessarily think of them as from and to measures, but just raw numbers, just breakpoints. And because I want to be able to account for event layers that have gaps by design, intentional gaps in coverage. Like a bridge is only going to be where a bridge is. So like say blue 1 here goes from 0 to 0.4. 0.4 is only a to measure. It's not also a from measure. So to simplify it, just get all these breakpoints into one list, which turned out to be my answer I needed. So just collect them all, remove duplicates. Obviously you'll have duplicates, 3 zeros, 3 ones, 2 0.5s here. Make sure they're sorted. I don't want to assume that they're sorted because they're coming from different inputs. And then somehow later on I'll figure it out, come up with a way to rebuild that from and to aspect. So effectively I'll get a table of route ID, from measure, to measure. So that's kind of part one, just the segmentation. And then try to bring the attributes back into the overlay segments. And I figured if I can get the route ID from and to for segments, I should be able to just, because I was already familiar with joins and testers. That's my bread and butter so far with FME. I should be able to just join those back to the input event layers one at a time and just compare the measures, because, and I have a slide for that later. I'm jumping ahead, but that's a MIDI to MIDI join. So I'll just compare the measures to see which event record that segment is within range. And also figure out a way to populate no data or NA for any gaps in coverage. And once I have that figured out for one event, it's just rinse and repeat for all the other event layers. So first, to get that segmentation, like I said, it turned out, well, the list approach was one method, and I had learned a list builder starts a list, and list exploder turns that into a usable table, because this list format, I don't really know what to do with it. It's kind of a whole different format or something. So list exploder just turns that into a usable table. And then between those two steps, you can chain different list specific transformers. So list duplicate remover and list sorter, pretty self-explanatory. And then I found list range extractor, which I'll explain that in the next slide, but that's going to help me recreate the from and to aspect out of these breakpoints. And the list builder, it has that group by checkbox, so I can have one list for each route ID. Luckily, fortunately, the list explorer does not make a table for each and every route ID. It's still just one table. And so it'll add route ID as an attribute. In fact, the list explorer, that table only includes fields that are involved in the list. So you don't even need an attribute remover or keeper upstream of this. So route ID is in here. The measures, obviously, that's what I'm making a list of. And this min and max field, because I did the list range extractor. It also includes an index, which is just a counter starting with 0. And I skipped this first part just to kind of take you on the journey I went through. I was hoping the list builder, it allows you to input more than one field. So I fed it from measures and to measures, thinking they're both numeric fields, double. And but no, just like group by route ID, it makes a separate list for from measures and to measures. So after a good bit of trial and error, I kind of had a eureka moment and realized, wait, why don't I just do an attribute creator before doing all this? And each event layer gets 2 attribute creators, and just do the same attribute twice. And the name doesn't matter because it gets changed later. But the letter M, and then I just populate that with the events from measures, and then again do it for the to measures. So now I'm feeding all the same attribute into the list builder, so it truly is one list of all measures, all breakpoints for the route. So the output of this, it is a table, and it's got route ID, all the breakpoints, the lowest and highest for that route ID, and a counter. And so next, I just need to have this say route ID, from measure, and to measure. So yes, so GPT suggested a list copier. Maybe I'll learn what that's truly intended to be for one day. But yeah, I couldn't figure out what it was getting at. Kind of, but not really. And then I figured, well, I could just output this thing twice. I don't need a transformer to do that. And that's when I found that list range extractor and had the idea of just output this twice and do 2 different testers. M does not equal max, and m does not equal min. So that's how I have this list twice. And one of them I just get rid of the last, one I get rid of the first measure. So effectively these will become my from measures and these will become my to measures. And I was ignoring this index field that was added by the list exploder for quite a while. And then I realized I tried to join these by route ID. Bad idea, because I had route ID and good from measures and null to measures, and then vice versa, null froms and good to measures. But I'm looking at they both had this index number. And so I realized these will always have the same number of measures, because I go back, I output this, that's just output twice. I did remove duplicates and sorted, so this is the same exact number of points. And for both of them, I only eliminated one. So there's no possible way these will have a different number of points here or items in that table. Except that this one, the index is starting at 0. And this one, it's starting at 1 because I got rid of I removed that 0. So I just needed to add 1 to this index. And a little funny side story, anybody new to FME, if you're struggling with it, if it's any consolation, I had a really tough go at just adding 1. Felt like a literal baby. And yeah, I had to go to lunch and gave up on that afternoon and worked on something else and came back to it another day and then figured out, oh yeah, attribute creator is like field calculator, and go to the math functions and find how to add 1, kind of figure it out. So by adding 1 to that, now they're in sync. Now both of these from and to tables start at 1. They go from 1 to 6. So I can join by the index number. The feature joiner will be grouped by route ID, but the actual field that I'm joining on will be the index. And so now I have my table of route ID, from measure, to measure, that represents the overlay segmentation. And I just need to get these attributes in there. So, like I said earlier, I join to one of the event layers one at a time. This time I do join by route ID because the original layer input events, they're not going to have these new index numbers. So it's going to be a many to many join. So I'm singling out this segment number 2 here. It's going to join to both blue 1 and blue 2. Oh, okay, I skipped this part here. That's all right, I'll come back. So the query I was planning on doing, as long as I keep the from to measure field names different, they'll both carry over in that join, and I can compare them. So if the overlay from measure is greater than or equal to the events from measure, and the overlay to measure is less than the events to measure, like 0.3 is greater than 0, 0.4 equals 0.4, or 0 equals 0, 0.3 is less than 0.4. You know, this is within range of this. And segment 1, it's within range of this. Segment 2 is way over here. It's not associated to this at all. So I just need to remove the back thing right now. Get it. So I got to remove that false join, that byproduct of a main join. So I just do that with the tester. So I keep the good one, remove the bad one. And for gaps in coverage, well, first off, if any of these overlay segments do not join to an input event at all, that simply means that joined by route ID, that means that event layer has not a single record on that entire route, but other events might. So I don't want to remove those, but I do want to populate them with NA. So there's that unjoined left or unjoined right out of that feature joiner. So I want to carry those forward and just populate that relevant attribute name with NA. But for ones that do have events, but there's a gap in coverage, they're both, so segment 3 and 4, they're both going to join to both of these events, but that's all going to fail the this from a to tester. So, but I don't want to keep all of the fails because, like this previous example, this is just kind of a junk record. So then I realized, what if I join the passes and the fails together, and the unjoined fails, that means like segment 3, it only fails twice and it doesn't pass. So there's no pass to join to. So the unjoined fails represent gaps in coverage. But I only need one per segment, so I give it a duplicate filter, and then I don't care which attribute it joined to, blue 1 or 2, 1 or 2 gets overwritten with NA. And that was pretty much it for the attribution. Then it just goes on to the remaining events. Now, preparing for this presentation, I realized 2 things that I wanted to not fix but improve on the workbench. I wanted to talk about how if your input event data has overlaps, and so let's pretend green A overshoots a little bit and goes to 0.6 here, and B starts at 0.5, so you'll have an overlap at A and B right here. This segment 4 will it'll pass that tester for both records here, A and B. And maybe a standard overlay tool does the same. I don't know. I don't remember. But yeah, I think it's good that it doesn't just kind of coin toss by object ID or something. It keeps both for better or for worse. And so it's reflecting that source data. So I wanted to point that out. But then while I was kind of planning that statement and that picture, I realized, oh, wait a minute. If this occurs where a later event has a gap, well, that join the passes and fails and duplicate filter, I had these duplicate filters set to only route ID and segment number and from and to measure. I don't think I needed from and to measure, but I realized I needed to also include any relevant attributes from previous events in this attribution part. So I don't want to check on the blue attribute because it'll be a 1 and a 2 here. Like I don't want to keep both. I just want to keep one of these and then override it with NA. But if segment 4 was already duplicated because of a previous overlap, I want to keep both A and B. So yeah, that was a minor correction that I realized I wanted to make there. And then another thought I had just yesterday, and I haven't made this correction yet. I don't know if we still have any backwards from or to in our, I mean, we got a lot of data, a lot of events, so I wouldn't be surprised. But then again, that's a pretty easy cleanup, so we might have already fixed that. I've seen it in just random spreadsheets I get from people. It's not common, but you know, someone just needs a map and they have you know, routes and from and tos. So if anything's backwards from measure greater than 2, like from 0 to or from 0.3 to 0, that's not a problem for roads and highways. It can draw that event. But the way I'm doing this, that would fail that measure tester because this segment 1 here, 0 is less than 0.3 and 0.3 is greater than 0. So it would fail that. So I would need to correct any backwards from or tos. And so, yeah, plan on adding a tester early after the reader for each event from greater than 2, and then attribute creators to flip those from and tos. So I'm not actually editing source data. It's kind of the magic of FME. You kind of do things virtually, so to speak. So that's the last little JPEG slide I had here. So that was all abstract. We can look at this actual workbench, and this looks like a behemoth of a workbench to me, at least. But this effectively is part 1, the segmentation, and part 2 is here and I have 6 events in here. So this is just kind of copy, paste, rinse, and repeat. So it looks like a lot more than it is. And then this horizontal dividing line here is more or less of an optional step. So I wanted to incorporate our routes into the overlay as well, because we have a ton of data. It's not all perfect. And also, if we did not have multi-part routes, this would be much, much shorter. It would only be a few steps. But yeah, we have some Euclidean distance gaps in some routes, and some events do not acknowledge those gaps. They don't stop at those endpoints. They just kind of pass right over that gap. We also have some events that exceed the end measure of the route. And I even found one that had a -1 from measure, but all our routes start at 0. Well, most of them. Yeah, none of them start with a negative. So anytime there's event data coverage that is out of bounds, so to speak, of the routes, this is all tabular. I output a table, which I bring into ArcMap or ArcPro, display route events or make route event layer, turn into a feature class, and you get that checkbox for generate location errors. So I wanted to incorporate the routes into the segmentation, but for part 2, for the attribution, instead of pulling in an attribute, I'm using similar steps, but instead of populating NA like a gap in coverage, well, a gap in coverage for the route, that's kind of the inverse. That means I have event data, but there is no route there. So that would effectively become a location error. So I wanted to see if I can filter out those within the workbench before bringing it into ArcMap or ArcPro. Mostly just to see if I can do it because I'm just experimenting with FME. But also for a practical purpose, is that partial match for the 2 measure, where most of those is just because of rounding, and I did want to round data in here. And so if it rounds up, it slightly exceeds the route measure. It's not a real error. Or it could be a whole mile past the end of the route. So there's extra steps to determine which is which. Yeah, I wanted to filter out those kind of location errors. And well, I guess, yeah, I don't want to go into detail on this. I could, but I don't think we have time for all that. So in fact, I'm going longer than I planned. Okay. Yeah, so I got a query on this, just active records, and just in case we get any zero shape links, I don't want to break the workbench. Round the from and tos, and then it goes off into 3 paths. So these 2 tunnels go up to, what is this? Okay. 2 attribute creators. So there's my M is from, and the other is to, so they can all feed into the list builder. Duplicate remover, sorter, range extractor for the min and max, exploiter to make it a table. And then here's my 2 M does not equal min and max for my from and tos. Remove those min and max fields, don't need them anymore. Rename M to an overlay from M. And then here's where I add 1 to that from overlay index. Same for the 2s, but I don't need to add 1. Feature joiner, joining by the index, but grouped by route ID. And so that's my segmentation. So here I join it to these routes or pieces of multi-part routes, but I don't populate NA, so it's fewer steps. I'm basically ignoring this. We're going straight down to here. So I have an attribute keeper. I only care about the relevant attribute, route ID from and to, joined by route ID. So here is where unjoined left. That's where my overlay segments do not join to this event. So NHS, just give any of those NA. Probably a bad example because NHS is full coverage, but I just do the same for all events. This tester, yeah, so here's the main one, the from greater or equal to the event from overlay 2 less than or equal to the 2. So if they pass, I can just get rid of the event from and to measures and bring it into this collection point here. And here's where I join the passes and the fails. This time joined by overlay index, and the unjoined right are my gaps in coverage. And this duplicate filter, only route ID, overlay index from and to doesn't hurt. I don't think I needed it. But for subsequent events, I also include the previous. Oh, I didn't do it here. All right, that was a different workbench copy. Yeah, so that's a functional system, but I check on NHS, the previous one. And then I can remove those from and tos. And then use attribute creator more as a field calculator this time. Just overwrite NHS with NA. And yeah, it's just rinse and repeat for the remaining attributes or events. In the end, I can finally get rid of the overlay index. Don't need that anymore. At first I had the overlay from and tos as our proper from and to, and then I was renaming all these events to event from or to. I figured it'd be a lot less transformers to let all these remain the same and have a different name for the overlay, and then just rename it once in the end. But this is our standard from and to measure nomenclature. And yeah, FME I hear and have experienced, it kind of randomly creates duplicates sometimes. Not sure how, so just in case, I just kind of cap it off with that. If everything's the same, I don't need duplicates. And write out the table. So that's that. But I would like to, I see room for improvement. I would like to try to see if I can run make route event layer or replicate that in FME. So instead of outputting a table, draw it on the routes and have geometry in here as well. And then try to dissolve or unsplit lines if I have segments, neighboring segments with all common attributes, just merge those. But yeah, that's pretty advanced for me. I couldn't figure out how to do that. Yeah, and back to ChatGPT, I fully explained make route event layer, display route events and everything. And it from the get-go, it just started making up transforms that don't exist. So maybe with that AI assistant, I'll be able to figure it out. But yeah, that's all I got. I don't expect any questions, but more than welcome.
Thank you, David. That's really cool. You know, it's interesting because I'm sure a lot of us use FME to overlay route event data. So it's cool to see how different people do it differently. So if anybody has any questions, feel free to post in the chat, raise your hand, unmute yourself. But again, I really appreciate you presenting, David. We are always looking for more presentations. Like I said, different DOTs use FME for the same thing, but they do it in different ways. So it's kind of cool to see how everybody's doing it. All right, well, I don't see any questions in the chat. So stay tuned. I'll be sending out a request for more presentations in a few months. Like I said, we meet quarterly, so keep an eye out. And thanks again, Sienna, for presenting as well. All right, everybody have a great day. Thanks.